Kia ora koutou, Reese from QuickSense here, and today we're looking at combined transformations. Now with this question here, we can see that the point A, 3, 4, is translated by the vector 1, 2, and then is enlarged. So let's deal with these in turns. So if I'm translating A, which is 3, 4, I'm firstly going to write it in this form here, and then I'm going to shift it by this, which is equal to 3 plus 1 and 4 plus 2. 4 over 6. So this is my first transformation. The second transformation, where I scale it, I'm doubling the distance now from the origin. So what does that mean? Well, doubling there are two lots of, so we can do the same thing we did above. 4, 6, and then another lot of 4, 6. That's equal to 4 plus 4, 8, 6 plus 6, 12. Or we can write this coordinate form 8, 12. In this next question, we're looking at moving this unshaded triangle and placing it on top of this shaded triangle. And it's giving us two transformations in order to do it. Now the way I'm going to do this originally, or to begin with, because I'm going to go through two different options, is to shift it up with the transformation 0, 8. Now what this means is it doesn't move left or right, but we are moving each point up 8. So for example, this one here moves up 1, 2, 3, 4, 5, 6, 7, 8. And we're going to have each of these points matched in this way. In order to have the points match, I need to get this one to here. The way to do that is reflecting through this axis here, the midpoint, through y equals 4. Well, let's do that in blue. Another way we can do it is to move the bottom triangle 90 degrees. So what we do is we actually move it up. So we move it from this into this space here. We're shifting the whole thing 90 degrees clockwise, if you want to think of it that way. So 6 o'clock becomes 9 o'clock. Now what that does, if you can see, is it moves this space over to here, this space to here, and this space out to here. So we have this triangle here. Now the problem with this is we're close, but not close enough. This is right, but I need to move this one to here, and this one over to here. Maybe some of you can see it, but we have this axis here. And what's that axis called? Well, our first movement was a 90-degree rotation. And our second transformation, combining these transformations, is reflecting through y is equal to minus x. 6 here, minus 6. 2 here, minus 2. And this will reflect the unshaded object completely onto the shaded object.